You see,
Yes, sir.
this thing is very important. Okay, this question will come. See that we have some pages here, like 7, 0, 1, 2, 0, 3, these things. Okay, now, so I have to go to the particular algorithm that is called the fast in fast out algorithm. In the process scheduling, you have learned about the fast come fast serve algorithm. In this particular algorithm, this is called the fast in fast out algorithm. Okay, so basically these pages will be replaced based on their order of occurrence. Okay, how they have came. So first you go to allocate the memory. Now this is very important, that what is the frame size. Suppose you are going to take 3 size frame. Okay, 3 size means that there are 3 number of pages you can keep at one time. Okay, we may also we may also increase the size to 4. We may also increase the size to 5. Okay, so number of frame size can be increased. Okay, we are going to take 3 frame here for the first one. Now what is happening here, suppose 7 is the first one, so in the memory everything is blank, every frame is blank. I have kept that one in the first location. So this is actually page fault. This is one page fault because the page was not present in the location in the memory, so I have taken as the page fault, one page fault. Then this 0 is actually kept after 7. 0 came here and it is blank. 1 1 came after 0. Okay, next page is 2. 2 is found in this location or not? 701 is here, so 2 is not matched with the any element or any pages. So what we have to do, we have to replace 2 with the first one, first come first serve. Okay, or first in first out. So among these 7, 0 and 1, what came first? 7 came first, right? 7 came
Yes, sir.
first, so therefore 7 will be replaced with this 2 and 2 will come in place of 7. Next, 0 0 is present here, so 0 will not be replaced. Next, 3 3 is not present here, therefore 3 will be replaced with what? With the next element, that is 0. So 3 will come in place of 0. Okay, therefore 2 3 1 will be here. Next, 0 0 is coming, so 0 will be replaced with what? The next element, that is 1. So 2 3 0 will be there. Next 4 is coming, so 4 is present in this location, it is not. Okay, therefore 4 will be replaced with what?
2,
2. So 4 3 0 will be happen. Then 2 is coming, now 2 will be replaced with what?
3,
Yes, 4 2 0. Then 3 is coming, 3 will be replaced with what?
0,
Yes, 4 2 3. Then 0 is coming, so 0 will be replaced with
4.
4. So 0 to 3. Okay, then 3 2, these are present here, so these will not be the page fault. Next, 1 is coming, so 1 will be replaced with
2,
2.
2.
0 1 3. Okay, then 2 will be replaced with
3,
yes 0 1 2. Now 0 and 1 is present already here, so this will not be the page fault. Then 7 is coming, so 0 will be, so here after 2 0 will be replaced here, so 7 1 2. Okay, in place of 0 we are keeping 7 here, 7 1 2. Then the next one, so 0 is coming here, 0 is not present in this location, therefore 7 0 2 will be here, because in place of 1 we have to keep 0. Next 1 will come here, so 1 will be placed in place of 2, therefore 7 0 1. Now we have to count the number of page fault. So number of page fault is here, you can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 15 number of page faults are here. So one question I have given in the examination, that is, you have to tell number of page faults by using FIFO page replacement algorithm. Okay, and I have given a bit string, so you have to do this one. Is there any problem, anyone? You can tell. Is it clear to all of you, or I can repeat?
Yes, sir.
Okay, next one I have given, that is the algorithm, optimal algorithm. Okay, and the another one is there, that is I'm telling later. Okay, so first the optimal algorithm. Optimal means what? So in the FIFO, that is first come first out, first in first out. Okay, or first come first serve. In the optimal, you can see 7 is not found initially, it was blank there, so we have kept 7. This is page fault. 0 is came after 7, it is page fault. 1 came after 0, it is page fault. 3 page faults initially occurred. Now 2 came. Okay, 2 will be kept where? So optimal algorithm tells that one page that is may be required later, okay, or that may not be required. Okay, so we may think about that the page that is not required further, okay, that is not required further. So you see, after these 2 there are many pages from 0 3 0 4 2 3, these things. Okay, among the pages, among the pages that are present here, sorry, that are present here, this 701. Okay, which pages is the farthest one? Can you tell that one? Can you see that one?
7.
Yes, 7 is the farthest one. Okay, because 1 is present here. 2 this 0 is present here and here also. Okay, but the farthest one is the 7. 1 is present later also, but still we can see 1 is present here and here in this location. Okay, if this thing happens, so out of this 7 0 and 1, we can see that 0 is present in many location, 1 is present in many location. Though 1 is present at the end, still 1 is present in this location also. Okay, we have to consider 7 as the victim, and 7 will be replaced with 2. Any question, anyone? Next, 0 is coming. 0 is hit, 0 is found here, so 0 will not be the page fault. Next, 3 is coming. Now after this element, you check that what is the farthest one among this 201. Among this 201, 2 is found here, 0 is found in many location, and 1 is coming later. This one or this one or this one, they are coming later, because 2 is found before 1 and 0 is found before 1. Okay, so we have to replace this 1 with the next element, that is 3. Okay, next 0 is hit here, so 0 will not be replaced and 0 will not be the page fault. 4 is coming here. Okay, now 4 will be replaced with what? You see that among these 2 0 and 3, among these 2 0 and 3, which is the farthest one after 4?
0.
0. Therefore 0 will be replaced with 4. 2 4 3. Are you getting or not?
Yes, sir.
Next, 2 and 3 is found here, so it is not the page fault. Then 0 is the page fault here, so 0 will be replaced with what? After this 0, which one is the farthest one? See that 2 and 3 is found here, but 4 is never present here. 4 is not present here, so 4 you have to take as the victim. Means that 4 is not present in the future location. That means we have to consider that 4 will not come. 4 will not come later. Okay, so we are going to replace this 0 with in the location of 4. So 2 0 3 came. Then again 3 and 2 is the page hit. 1 came here. 1 came here. Now what to do? So after this 1, what is the page? So you see that in this 203, among these 203, which is the farthest one? 2 and 0 is found, but 3 is not found here. Okay, so we have to replace this 1 with in the place of 3. Therefore 201 will come. Now 2 is the hit again, 0 is the hit again, 1 is the hit again. Okay, so this will not be the page fault. Now 7 is coming. 7 is not present in this particular frame, so we have to replace 7. Now it will check that whether, so you see that among this 201, which is the farthest one, 2 is not present, after 7. Okay, 0 and 1 is present, therefore 7 will be replaced in the place of 2. So 7 0 will 1 will come here. Okay, then 0, 0 is the page hit and 1 is the page hit. Okay, now we can count the page faults, that is 4, then 5 6 7 8 9, 9 number of page faults are there. Okay, but for the same reference string, in the case of FIFO there is 15 number of page faults. Okay, so generally FIFO takes more page faults, then optimal is there and another algorithm is there. Okay, so is it clear this optimal algorithm, or I can repeat later? I will repeat again. Is it clear to all of you, or I will repeat? This question will come in the examination. Okay, I am telling you. We have to count the number of page faults using FIFO optimal. Okay, and this LRU, the least recently used algorithm. So coming to the LRU algorithm, see,